For Unit 3, we're going to be talking about functions and relations, and we're starting off the beginning with talking about inputs and outputs and how that looks like in terms of a function and a relation. So an input is a value that you put in the machine, or in our case, we're going to talk about put in the equation. That's usually what happens. And an output is the value the machine gives back. And it is always true that the output depends on the input. So depending on what you put in determines what you get out. So when we start talking about inputs and outputs, there are two types of there are two words we can use to describe those inputs and outputs. And the first word is a function. You've heard the word function before. It's been used a lot. Specifically, a function is a rule that tells how one value depends on another. And the next part's the important part. For each input, there is exactly one output. So you put one thing in, you get one thing out. An example in the real world of a function would be social security numbers. When you put in one social security number, you get one person out. But a relation is a rule that tells how values depend on one another. But for this one, for each input, there is one or more outputs. So you put one thing in and you can get a lot of things out. So example, a name. Like if you have a name like Matthew. If you put the name Matthew in, even on Facebook, you're going to get back thousands upon thousands of Matthews. So that would be considered a relation because you put one thing in and you get back a lot of different things. So every set of points, every table, every mapping, every equation, every graph is considered a relation. Everything is a relation. But some of those that are relations are also considered functions. And that's why you have the function circle is inside of the relation circle. Because if something is a function, that means it's also a relation. But not every relation is a function. So in other words, a relation is always a function. I'm sorry, I wrote that wrong. A function is always a relation. But a relation is sometimes a function. So a function is always a relation is only sometimes a function. Sometimes you're going to hear, instead of input and output, you're going to hear independent and dependent, but those are very much the same thing as input and output. The input is the same thing as the independent. Easiest way I can remember that is it's my input, my independent, and it's in the parentheses here. It's what you're putting in. And then my output is on the outside. It's also my dependent. On a graph, these things also translate that the X's are my inputs and my Y's are my outputs, and the X-axis represents all the independents and the Y-axis represents all the dependents. So if I were to make a table over here, I'm going to call the left side my X's, the right side my Y's, and underneath each I'm going to list the words that we can use to describe these. So my X's could be considered my inputs. They could be the independents. They could also be the domain. We haven't talked about that one yet, but that should not be a new word to you. Our Y's are our dependents. They are our outputs. And they are our range. And that is always true. It may be a good idea for you to go ahead and write that down. The catwalk problem is a problem that you are going to most likely see on your quiz. So it says, why is the catwalk problem an example of a relation that's not a function? Well, you need to understand what a catwalk is. And the easiest way I can explain it is, rather than talking about a catwalk, to talk about if you had a wall. Here's a wall, okay? It's not a rectangle, it's a wall. In the wall, there are support beams. Support beams establish the foundation, or the structure, of the building. So these support beams are about every 16 inches apart. And when you think about this support beam, it's going to touch the building at two places. It's going to touch at the roof, and it's going to touch at the floor. So the catwalk problem is not a function because it touches in two places. So that's why the catwalk problem is not a function. You do not need to worry about the farmer problem. That's not going to be a part of your notes or a part of your quiz. But just don't forget that an example of a function, I'm going to write this out, a function example that's a real world example would be something like social security numbers. For you, it would be your student ID number. Driver's license numbers, credit card numbers. All of those things are functions because when you put that one number in, you only get back one person. Okay? But an example of something that is a relation, just a relation, in other words, not a function, would be a name or an address. At least the city, or even just the address, because like if you put in your home address, well, there may be 3 or 4 people that live there, so you put in one address and you get back 3 or 4 names. That's going to make it not a function.